A deer-vehicle collision occurs when one or more deer and a human-operated vehicle collide on a roadway. It can result in deer fatality, property damage, and human injury or death. The number of accidents, injuries, and fatalities varies from year to year and region. In the United States, an estimated 1.23 million deer-related accidents occurred in a one-year period ending June 2012, resulting in $3,305 in average property damage. The largest proportion of such accidents occur in November. In 2000, of the 6.1 million lightweight motor vehicle collisions reported in the U.S., 1 million involved animal vehicle collisions. Deer vehicle collisions lead to about 200 human deaths and $1.1 billion in property damage every year. State and federal governments, insurance companies, and drivers spend an additional $3 billion in an effort to reduce and manage the increasing number of deer vehicle collisions. The term deer vehicle collision is commonly annotated throughout safety agencies as DVC. In Canada during the year 2000, there were nearly 29,000 animal vehicle collisions resulting in property damage only. An additional 1,887 involving non-fatal injuries, and 23 fatal collisions. History. Deer vehicle collisions have occurred since roadways have been built in close and direct proximity to direct habitat, also known as deer habitat fragmentation. White-tailed deer, the most common deer involved in deer vehicle collisions, have steadily increased in numbers since the turn of the 20th century. Currently, it is estimated that 20 to 30 million deer populate North America. The actual number of animals killed in deer vehicle collisions is not known because no such database exists. In 1981 study, it was concluded that large animals, which included deer, accounted for 26% of animals killed each year in collisions with vehicles on interstates and country roads. The expansion and technological advances of roadways in the U.S. have increased the number of deer vehicle collisions. The increased amount of habitat fragmentation due to expanding technology has increased the likelihood of a deer vehicle collision. In the United States, the state with the highest number of deer vehicle collisions is Pennsylvania, with an estimated 115,000 collisions in 2013 causing $400 million in damage. West Virginia is the state with the highest risk that a motorist will hit a deer while driving. Contributing factors. The main contributing factor of a deer vehicle collision has been contested among studies and statistics. Many factors are yet to be identified or understood. At this point, a main factor in all deer vehicle collisions has not been concluded, but the most argued is the proximity of roadways to deer-populated forestry. Significant factors also include urban population and deer density. Also, studies have shown that, nationally, most deer vehicle collisions occur between May and November because of deer mating season and foraging before the winter months. Habitat fragmentation. Habitat fragmentation occurs when human technology encroaches upon the natural habitats of animals. As human beings live in closer proximity to animals, they are more likely to encounter one another. The most common type of habitat fragmentation across the United States is roadways and highways in forests and other deer-inhabited areas. Because highways are isolated points of fragmentation, deer wander about them freely because they see little to stay away from. Roadways and highways located in sparsely populated areas are usually built along rivers and lakes of mountains and plains. These areas attract deer because they render safe havens and excellent foraging. Roadways and highways within densely populated deer habitat lead to more prevalent deer vehicle collisions. Time. A contributing factor to deer vehicle collisions, as preventable as it is prevalent, is the time of day at which motorists travel through deer habitation. During the daytime, motorists can more easily see and avoid hitting deer. At night, most especially during the dusk and dawn hours, deer are much harder to see, and therefore harder to avoid hitting. Premier technological prevention. The U.S. government does not sanction any specific manufacturer that may reduce or monitor deer vehicle collisions. The investigation and implication of deer vehicle collision prevention methods remains a responsibility of state governments. Such products are usually heavily tested and studied before being endorsed by them. State organizations such as the Departments of Transportation and Game and Fisheries usually handle the investigation of deer vehicle collision prevention methods and products. State wildlife agencies have much concern for the preservation of deer and other wildlife that become involved in vehicle collisions due to roadway expansion and development. Deer whistle. The deer whistle is the most widely studied and scrutinized form of deer vehicle collision prevention method. Deer whistles are products that attach to a vehicle and act as an alarm system for deer and other wildlife. The manufacturing of deer whistle products has emerged into a multi-million-dollar industry. The manufacturers advertise that ultrasound, which they say deer can hear but humans cannot, is emitted as air passes through the whistle. The deer hearing range is 115 Hz to 54 kHz. Most deer whistles are about 2 inches long and a bullet shape. They cost between $5 and $25 and are designed to be attached to the bumper of a vehicle. When a vehicle moves faster than 35 miles per hour, a whistle sound is induced which is believed to ward off animals from a roadway. The deer whistle is marketed to prevent deer vehicle collisions. The effectiveness of deer whistles is disputed among agencies because of the conflicting reports available. The study and documentation of deer whistles is generally poor, and a conclusive decision about the effectiveness of the deer whistle cannot be made. Some research has been published about the function and capability of deer whistles. Some manufacturers claim that deer can hear the whistle up to a quarter-mile away, but no research has solidified that claim. Another point of concern is that the amount of noise from a vehicle may compromise the clarity of the deer whistle. Because the whistle is vehicle-mounted, there is little that can be done about mitigating vehicle noise. Others also argue the whistle's location on the vehicle as being susceptible to dirt and insects, which would eventually clog the passageway of the whistle, rendering it useless. The idea of a non-air activated whistle has been discussed, but little research has been done on the effectiveness of such products. Deer whistles generally have a questionable level of effectiveness but are advertised as aiding in the prevention of DVCs. A concern among studies is the impact the whistle has on the psyche of the driver and the driver's sense of security. UV lights. Deer see slightly differently than do humans. A deer's color vision is based upon two types of cones which sense the shorter and middle wavelengths of light. This is called dichromatic vision. Deer, and most game animals, have light sensitivity in the approximate range of below 320 nanometers to 640 nanometers. This means that they cannot see red or green, but can see UV. Thus, what appears to humans to be a very bright blazing orange is seen as possibly a gray, dull yellow by deer. Conversely, a deer's ability to see light at higher frequencies means they can see UV blue light that is virtually invisible to humans, possibly better than humans see blazing orange. The ability to see in the UV spectrum truly sets deer and animal vision apart from humans. UV light is generally damaging to eyes, particularly in the long term. Hence, a pigmentation is present in human eyes that helps filter out UV light. Deer have no such filter and see well in the UV spectrum. UV light, invisible to humans, can literally glow to deer. It is theorized that UV lights as strobes mounted on autos might reduce the rate of collisions and concomitant loss of life. This should also reduce the rate of collision of birds with windmills used for power generation.